Our next speaker is called Olivier. He's a contributor on many great tools like CocoaPods, and he wrote many tools himself, like OH, HTTP stubs, and the SwiftGen. He had a great talk at NS Spain last week, and today he's here with us to talk about mixins versus inheritance. So welcome on stage, Olivier HALLIGON.
So hello everybody. I hope you have a great conference so far. I'm here today to talk about mixins, what they are first, and how you can use them to improve your code in Swift. So a few words about me. I'm an iOS architect, so I love design patterns and stuff. I love also sharing and teaching and speaking with others. You can find my blog and my Twitter. Don't hesitate to come to me after the talk to speak. I would love that. And you probably also know me, as Simone said, from my open source contributions. But let's dig right now with the problem. So the problem we're gonna try to solve today is about inheritance mainly. So imagine you want to implement a burger menu in your app. One way to do that, if you imagine that a lot of view controllers in your app as burger menus, you're probably gonna start with a common view controller that will implement all the setup for your burger menu, so that the next step would be to inherit from this burger view controller and have all the setup done for you every time. But that's problematic because multiple inheritance isn't allowed in Swift, and as in many other languages, for multiple reasons. So if you happen to need a table view controller, you will not be able to inherit both from table view controller and burger menu. So that's a limitation of inheritance, and that's generally the problem we have with that. And of course, there is a composition to the rescue. You probably heard about composition over inheritance. The idea of composition is to create a class that will manage your burger menu. Instead of inheriting from that class, you will compose with it. So that means that now your view controller 1 and 2 will use that burger menu manager, or whatever you call it, and now you'll be able to use that in your table view controller. So that's the basic idea of using composition instead of inheritance, but today I'm here to talk about the third solution to that problem, which is mixins. But I know my talk is right before lunch, and I don't want you to be too hungry, so I will stop talking about burgers, and I'll take some more interesting examples, like sci-fi characters, because everybody loves sci-fi, right? So let's say you have an application that will need to represent sci-fi characters, like those four. You will start to model those as probably classes, but you will realize that they have some common traits, like some of them are humans, so probably they share some common behaviors. Some of them are alien, so same probably common behaviors there. But you also realize that some of them have abilities like time traveling or flying. And if you were to model that with inheritance, you couldn't, because you will have multiple inheritance. Like, for example, Iron Man would be both a human and a flyer. So, of course, you could use composition for that. But if you look closer at this representation, you'll realize that although human and alien are identities, time traveling and flying are more like abilities. So that's what those characters can do more than what they are. And what better way to represent what an object can do than protocols, right? That's what there are for in Swift and in Objective-C as well. So by realizing that, you can now think about representing those abilities with protocols. That's what we call traits in the Mixins Traits pattern. But we'll use some specific kind of protocols, which are protocols with default implementations. The idea, if you don't know about default implementations, is that with an extension, you could actually provide a default implementation for any of your methods in your protocol. And that means that when you conform to that protocol, if you don't provide a specific implementation, you will have the default implementation for free. So if we have a time lord there, just by the fact that we conform to time traveler, we'll have the travel2 method for free. And we can call that without providing an implementation in the time lord. And of course, same for doc.emerald is a time traveler. So because we conform to time traveler and we have a default implementation, we'll have this implementation on all the instances. And that's what I call mixins. Mixins are actually protocols which provide a default implementation for every method that they declare. And what makes them great is that you just have to conform to a protocol and you will have everything for free. So if you look a bit closer at these examples, you'll see that it kind of looks like inheritance because you mark that a time log is actually a time traveler and you will get the implementation from a common implementation there. So it kind of looks like inheritance, but it actually is protocols with different implementations. So you don't have all the drawbacks of the inheritance problem. So with those tools, we can declare all our abilities. We can totally mix inheritance for the identities there with protocols with different implementation, so mixins there. And we can mix them without having the problems that we saw before, because now our time travelers can both be a human and a time traveler. So if we look at a standard implementation there, we can see that every class can both inherit from something and conform to something. That's the beauty of protocol-oriented programming. And we still get every default implementation of time traveler or flyer there. And what makes this pattern great also is that by using protocols, you can easily add abilities to your existing classes. So for example, if we were to add some space traveling ability, you can declare a new mixin there, so protocol default implementation there. And you can really easily add this ability to an existing class without having to redeclare or modify that class declaration. And we do that with extensions in Swift, because we can just mark an extension over an existing class like Time Lord or Superman. We can add this new conformance there, and we don't need any new implementation there. We just get the default implementation just like that. So it's easy to add ability even after the fact. And just like that, you can now ask Doctor Who to travel to Trenzalo. So I know sci-fi characters are great, but usually you don't have nice apps with sci-fi characters in it. So let's focus more on a practical example. I bet you all have applications with table views and table view cells. The problem I don't like with table view cells is that they mainly use an API that is string-based. So you use reuse identifiers in those table view cells. You'll have to make sure that the reuse identifier used match the custom class of your cell. But I don't know if you're like me, but for like 90% of the time, every custom cell I use happen to have a reuse identifier that has the same name as a class. So let's model that with Mixins, of course. So we can just create a Mixin there, which is called Reusable. Every class that conforms to that Mixin will provide a reuse identifier. And the perfect default implementation for that is that the reuse identifier, which is a string, will actually use the name of the class for its reuse identifier. So for those of you who don't know this, it's actually the same as an string from class in Objective-C. So you get the string representation of the class name. And now that we have this, we can just make each of our custom cell class conform to that Mixin. And because it's a Mixin, you don't need to add anything, any new implementation to that. You just get the reuse identifier for free. So before that reusable, we already had this method. And now we just added this conformance there, and we really have nothing more to add. And with that, we can now call this Apple method, like decureusable cell. So that's the Swift3 API, for those of you who don't use Swift3 yet. That's the same as decureusable cell with identifier for index pass. So the typical deque method you use. But now instead of passing a hard-coded string for a reuse identifier, we can now ask the type its own reuse identifier that we just got there. So if we have a type like custom cell1, this will use custom cell1.reuse identifier that will be the custom cell1 string. That's so useful to use that this way that we can make an extension on UI table view to be able to use that everywhere. So let's do that. We can now create a new function on UI table view called decureusable cell that will take a type as a parameter instead of a string, and it will just wrap our call we just made previously. So with that, you can now call table view decureusable cell with a type that will be custom cell1. So now you don't have to create constants or hard-code strings when you deque a reusable cell. You have some auto-completion, well, if Xcode is in a good mood. And you got some type safety there. But not quite type safety just yet, because if you look at the declaration there, you will realize that this method for now just return a generic UI table view cell. And that's too bad, because we already know that we want a custom cell1, so why can't Swift return actually a custom cell1 instance for us? So let's do that. To improve that API, we're going to use some generics, so I hope you're going to bear with me there. First, we replace this reusable type with a generic parameter called t there. So t is a generic parameter. It has to conform to reusable. And now we just use t.type. But by doing that, now we can add some more constraints on t. Because until now, we only said that t had to be reusable, but nothing said that this reusable class, this type that conformed to reusable, had to be a table view cell. But that doesn't make any sense to use our API with something other than a table view cell. And now with this where constraint, we can now be sure that our generic t parameter is both a table view cell and conform to reusable. And one more thing we did with this generic type is that now we can actually return the exact type that we requested, so t there, instead of UI table view cell. And once we have that, we can actually now have a custom cell1 as a return type. So now cell1 there is actually a custom cell1 because thanks to Swift type inference, we know that type is actually custom cell1.self, so t is custom cell1, so it will return a custom cell1. And by doing that, your table view cell for row at an XPath implementation that will use those can just deque a cell and just call some APIs directly on the expected type. So you don't have to downcast at call site, because that's already done in the extension. But I'm kind of a perfectionist. I don't like having type there, having to explicitly mention type as a parameter. That doesn't sound really Swifty to me. So instead, what if Swift could infer that type for us? So if we give, if Swift somehow has a way to infer what this T generic type is, maybe we can then tell Swift to use this T.self as the default value of our type. And if we do that, we can get rid of this parameter because the default value of that parameter will be inferred by T. Well, that sounds right, but that actually doesn't work just right now. Because if you do that at call site, for now, Swift doesn't have a way to know what T could be. So you'll have to give some hint to the compiler to help him know what T could be. So yeah, of course, we can bring back that type parameter, but that's not the, the thing we want to do. So instead, we're going to give some clues to the compiler, and there is multiple ways to do that. The first one is to use as operator. So don't be confused there. This as parameter is not actually the same as question mark or as exclamation mark. That's not downcasting. That's just a hint to the compiler, because the compiler knows that there is multiple variants of the reusable cell there, and we just tell the compiler that we want the variant, the one that will actually return custom cell 1. So that's not calling the method then downcasting. That's just calling the method that will actually return a custom cell 1. And with this int that we gave to the compiler is now able to know that we want a method that will return a custom cell 1, so it will infer that T should be custom cell 1, and it will back infer that T.self is actually custom cell 1.self, and it will be able to ask for its reuse identifier in the implementation detail. So I don't know about you, but if you look at what it looks at call site, it's now kind of beautiful, because now you don't have hard-coded string, you don't have to provide a constant for your reusable identifier. You have type safety there. You have auto-completion. So the compiler can also give you errors if you happen to try to dequeue a cell that is not reusable, not marked as the reusable, or if you made a typo in the type name. So you got all those safety for free, and all that just by marking your custom cells as reusable. So just by using this mixin, you mark that, you got a lot of implementation detail for free, and now thanks to our extension, you got a type safe and pretty nice API that doesn't use string type anymore. So we just saw that as is one way to help the compiler understand that your cell, you want the reusable cell to be a custom cell 1. There are other ways to do that. Another one is to explicitly type your variable. So there, Swift is powerful enough to understand that this method that you will call the reusable cell will its result, its return value will be affected into a cell 2 that is a custom cell 2. So is intelligent enough to infer that this T generic parameter you want would actually be custom cell 2. So that's kind of magic, and that's what I love with this API is that it uses a lot of Swift magic, but it makes API really powerful. And I've got one more thing for you today. Because reusable is kind of nice for table view cells, but we can go way further. Like we can also use a similar principle to use mixins and generics for collection view cells, but also for those of you who use storyboards. I don't know about you, but I don't like cobweb storyboards with a lot of scenes in them. I prefer to have sometimes even one storyboard file with only one scene in it, like a bit like a xib, but at least you have top layout guides and bottom layout guides with that. And if you do that, you can mark your view controller to be storyboard based. That's another mixin that I created. Basically, it gives you for free, again, because that's a mixin, so you have a default implementation. And it gives you a nice instantiate method that, a bit like Reusable, is generic and will create an instance from the storyboard named with the same name as the class, and will actually return the proper type as a return value, so like we did with the Reusable cell. And we can also do that for any widget that you could declare or design in a xib, for example. If you have a widget that you want to create, to use in many places in your application, you could design that widget, that custom view in a xib. For example, you will have mycustomWidget.xib with its own design. You make mycustomWidget as the nib files owner, and then you connect everything like IB outlets and stuff. And thanks to this mixin, you can now easily create a new instance of custom widget. So you could either create a new instance by code, like this, or you could even implement init with coder. This means that if you happen to have a storyboard that will need 3 or 4 of those widgets, you can just drag a UI view on your storyboard, then change its class to myCustomWidget, and it will automatically call init with coder, which will fill all the content of this widget with the content of the nib. So that's a lot of magic there, and that's all thanks to mixins, because just by marking the conformance there, you will get a lot of stuff for free. So I hope you realize how magical that is, thanks to generics, mixins, protocol with default implementations, and some Swift type inference. And you can really do powerful stuff there. So that's it for today for me. And so if you've got some questions, don't hesitate. And you can find all those mixins that I just presented on my GitHub. And you can also find 2 or 3 of my blog posts that talks about this kind of patterns and kind of techniques to improve your APIs. Thank you.
Thanks for this great talk. Maybe one of the first question you had, like backstage, Simone, maybe you want to ask it. It was like something that probably everyone is wondering right now. Is what's your favorite superhero?
Well, I think my T-shirt says it all. That's Doctor Who, right?
Oh yeah, yeah, right. Okay. Oh, we have one fan of Doctor Who. Okay. Okay, mine is Johnny Hive.
Yeah, mine too, honestly.
Aluminum. So that's that I really love this new approach of trying to put less code in the inheritance architecture, but it's kind of something that is possible, that has been possible for quite a long time right now. Some of it was even possible with Objective-C, right?
Well, you could do some stuff like composition and stuff like that in Objective-C, but you couldn't do mixins with Objective-C. because you don't have default implementation for protocols in Objective-C. That's what makes this kind of APIs really powerful, that you don't have to now provide an implementation for everything if the default one just fits your need.
Yeah, but it was like some of it was kind of already imaginable, and no one was really using it. So is it like kind of something that is hype right now? Or is it what's the history behind Mixins? Like, why did it came famous and popular? Because right now it's kind of getting a lot of traction, I guess.
Yeah, I think that's probably thanks to Krusty, right, with protocol-oriented programming. Now everything is great with protocols. You have a lot of possibilities that you didn't leverage before because it was all about object-oriented programming and inheritance. So now with protocol-oriented programming, we have a lot of new ways to do this kind of stuff. So that's probably why it gets a lot of traction now.
I use protocols extensions a lot. It's my favorite Swift feature. But when do you think it's too much? When are we abusing of mixins and
like too fine grained?
Yeah, because sometimes I feel like I'm just when it's too much, I feel it's hackish almost. I should maybe use more composition.
Yeah. Well, like I said in my talk, you can still mix and match mixins or protocols with inheritance. You don't have to go full way with protocols or mixins. And one of my favorite motto is just use the design pattern that fits your needs. So everybody is talking about MBVM or Viper or mixins or stuff like that. Those are great tools, but don't forget that they are just tools. So you just have to use the tool that's right for every kind of problem you have, and you don't have to go full way everywhere. So like Florence said, for RX, you can just start RX with network requests, and then add a bit more later. So that's kind of the same thing with protocol-oriented programming. You can just mix and match and pick what you need.
Okay. That's also tricky because sometimes you don't want to be blinded by some shiny new pattern, and so that's kind of hard. But with mixins, there's something that seems to be great. Is I get the feeling that you can start to inject mixins in your already existing apps, even if you want to put that in the real model data model part, and just try splitting big classes. Do you think it's like the good way to go, or?
Yeah, but I already think of one or two apps that I did with Mixin, and we actually introduced that gradually. So some of the table view cells that were already in the app, we still kept it the way they were, and new cells we made them reusable. Oh, okay. So you can totally go that way gradually.
So that's really great, like being able to jump in gradually. And like to come back on the history of what brought us Mixins, do you have some ideas on why people don't like at all multiple inheritance? I mean, except from the fact that we don't have it, but which is kind of a problem. But in any language today, everyone is kind of really scared by that. And what's the difference? The real difference between multiple inheritance and mixins?
Yeah, well, multiple inheritance has a big problem that's called the diamond problem. So basically, that means that if you have a class A and you inherit from this class A and create B and C, and then you multiple inherit from B and from T, that's really hard for the compiler to know if some of the function you call on this final class is the implementation from A, from B, or from C. So that's a really hard problem to solve, and that's kind of confusing for a lot of models if you have multiple inheritance. So that's the main problem of multiple inheritance that make a lot of languages avoid that kind of pattern.
Okay. Great. I guess it's all for this talk.
Yeah.
One more question?
That's fine for me. I think we need to move on to the next session, which is going to be the presentation of the classrooms. So I'd like to welcome on stage all the classroom speakers that will actually present their talk. And before that, of course, we can applaud Olivier.
Thank you.
Thank you.